Dear viewers, this is part 1 of the 3-part series on WBCs, granulocytes, the functional aspects in the medicine for anyone in the YouTube channel. WBCs, granulocytes, their functional aspects. Leukocytes, the major cells comprising inflammatory and immune responses, include neutrophils, T and B lymphocytes, natural killer cells, NK cells, monocytes, eosinophils, and basophils. These cells have specific functions such as antibody production by B lymphocytes or destruction of bacteria by neutrophils. Neutrophils are classically thought to be critical to host defense against bacteria. They may also play important roles in defense against viral infections. Normal blood leukocyte counts are 4.3 to 10.8 into 10 power 9 per liter, or 4.3 to 10.8 into 10 power 3 per that is cubic millimeter, or 4,300 to 10,800 per cubic millimeter cmm, with neutrophils representing 45 to 74% of the cells, bands 0 to 4%, lymphocytes 16 to 45%, monocytes 4 to 10, eosinophils 0 to 7, and basophils 0 to 2. The various leukocytes are derived from a common stem cell in the bone marrow. 3/4 of the nucleated cells of the bone marrow are committed to the production of leukocytes. Dear listeners, by the way, this educational video is made possible by Prescribe-On, the makers of e-prescription software for digital prescriptions, available freely for doctors on the website www.prescribeon.com. Doctors who are interested in this e-prescription can freely avail of its vast collection of more than 100,000 e-prescriptions. All WBCs arise from a stem cell which differentiates into a myeloblast and lymphoblast, from which derive the platelets, granulocytes, monocytes, and the lymphocytes. The myeloblasts go through various stages of differentiation, namely megakaryocyte for platelets, promyelocyte, myelocyte, metamyelocyte for neutrophils, eosinophils, and basophils. The myeloblast also differentiates into monoblasts and then monocytes. The lymphoblast differentiates into lymphocytes. Neutrophils. See the figure genesis of white blood cells shown earlier. Maturation. Important events in neutrophil life are summarized in the figure shown above. In normal humans, neutrophils are produced only in the bone marrow. The minimum number of stem cells necessary to support hematopoiesis is estimated to be 400 to 500 at any one time. Human blood monocytes, tissue macrophages, and stromal cells produce colony-stimulating factors, CSFs, hormones required for the growth of monocytes and neutrophils in the bone marrow. The hemopoietic system not only produces enough neutrophils, that is about 1.3 into 10 power 11 cells per 80 kilogram person per day, to carry out physiologic functions, but also has a large reserve stored in the marrow which can be mobilized in response to inflammation or infection. An increase in the number of blood neutrophils is called neutrophilia, and the presence of immature cells is termed a shift to the left. A decrease in the number of blood neutrophils is called neutropenia. The 4 cardinal signs of inflammation are rubor, that is redness, tumor, that is swelling, calor, that is pain, and dolor, that is heat. The chemical mediators of interactions of neutrophils with other cells are cytokines, GCSF, that is granulocyte colony stimulating factor, granulocyte colony stimulating factor, IL-1, that is interleukin, TNF alpha, that is tumor necrosis factor alpha. Neutrophils and monocytes evolved from pluripotent stem cells under the influence of cytokines and CSFs. See the figure genesis of white blood cells again. The proliferation phase through the metamyelocyte takes about 1 week, while the maturation phases from metamyelocyte to mature neutrophil takes another week. Myeloblast. The myeloblast with a prominent nucleoli is the first recognizable precursor cell and is followed by promyelocyte larger than a myeloblast. Primary granules appear. Promyelocyte. The promyelocyte evolves when the classic lysosomal granules called the primary or azurophil granules are produced. The primary granules contain hydrolases, elastase, myeloperoxidase, cathepsin G, cationic proteins, and bactericidal permeability increasing protein, which is important for killing gram-negative bacteria. Azurophil granules also contain defensins, that is a family of cysteine-rich polypeptides with broad antimicrobial activity against bacteria, fungi, and certain enveloped viruses. Myelocyte. The promyelocyte divides to produce the myelocyte, a cell responsible for the synthesis of the specific or secondary granules, which contain unique, that is specific constituents such as lactoferrin, vitamin B12 binding protein, histaminase, and receptors for certain chemoattractants and adherence promoting factors like CR3, as well as receptors for the basement membrane component laminin. The secondary granules do not contain acid hydrolases and therefore are not classic lysosomes. Secondary granule contents are readily released extracellularly, and their mobilization is important in modulating inflammation. During the final stages of maturation, no cell division occurs, and the cell passes through the metamyelocyte stage and then to the band neutrophil with a sausage-shaped nucleus. As the band cell matures, the nucleus assumes a lobulated configuration with neutrophilic granules. The nucleus of neutrophils normally contains up to 4 segments. The physiologic role of the normal multilobed nucleus of neutrophils is unknown, but it may allow great deformation of neutrophils during migration into tissues at sites of inflammation. Note: lobulations of neutrophils. Granulocytes, especially the neutrophils of the immune system, have lobed nuclei which aid their flexibility and migration. Smooth muscle cells have a spindle-shaped nucleus which must deform during muscle contractions. Spermatozoa have highly condensed nuclei which adopt varied shapes potentially associated with swimming efficiency. There are clear effects of nuclear shape on the transcriptional activity of the cell. Regulation of gene expression can be influenced by nuclear morphology. Cells can drastically remodel their chromatin during differentiation. The link between nucleoskeleton and the cytoskeleton at the nuclear envelope provides a mechanism for transmission of mechanical forces into the nucleus, directly affecting chromatin compaction and organization. Reference: Skinner BM, Chromosoma 126 to 195 to 212. Excessive segmentation, that is more than 5 nuclear lobes, may be a manifestation of 1. Folate or vitamin B12 deficiency, or 2. The congenital neutropenia syndrome of Watts, hypogammaglobulinemia, infections, and myelocathexis, that is WHIM, described below. Note: WHIM WIM is an inherited immune deficiency characterized by neutropenia, B-cell lymphopenia, myelokathexis that is characterized by myeloid hyperplasia and apoptosis, hypogammaglobulinemia, recurrent infections, and a marked susceptibility to human papillomavirus infection with resultant warts, condyloma acuminata, and invasive mucosal carcinomas. In severe acute bacterial infection, prominent neutrophil cytoplasmic granules called toxic granules are occasionally seen. Toxic granulations are immature or abnormally staining azurophil granules. This picture is of a neutrophil with multi-lobed nucleus with granules, Doyle bodies, glycogen, and mitochondria. This picture shows a neutrophil with vacuolization in cytoplasm in COVID-19 patients. See the figure of a normal granulocyte shown earlier and also the figure vacuolization in neutrophil in COVID-19 patients. Cytoplasmic inclusions, also called Doyle bodies, can be seen during infection and are fragments of ribosome-rich endoplasmic reticulum. Large neutrophil vacuoles are often present in acute bacterial infection and in some viral infections such as COVID-19 and probably represent pinocytosed internalized membrane. Neutrophils are heterogeneous in function. The morphology of eosinophils and basophils follows. This picture shows an eosinophil which has a bilobed nucleus and large bright orange granules. This picture shows a basophil with large purple-black granules that fill the cell and obscures the nucleus. Marrow release and circulating compartments. Specific signals including IL-1, tumor necrosis factor alpha, the colony stimulating factors CSFs, complement fragments, and chemokines mobile leukocytes from the bone marrow and mobilize leukocytes from the bone marrow and deliver them to the blood in an unstimulated state. Under normal conditions, about 90% of the neutrophil pool is in the bone marrow, 2 to 3% in the circulation, and the remainder in the tissues. This picture shows the 4 stages of neutrophil migration in inflamed tissues. 1. Free rolling neutrophils on the left. 2. Adherent neutrophil to the capillary wall. 3. Neutrophils undergoing diapedesis. 4. Neutrophils in the inflamed tissues. This is known as migration. See figure migration of neutrophils from blood into inflamed tissues shown earlier. The circulating blood pool exists in 2 dynamic compartments, one freely flowing and one marginated. The freely flowing pool, number 1 in the figure, is about 1/2 the neutrophils in the basal state and is composed of those cells that are in the blood and not in contact with the endothelium. Marginated leukocytes are those that are in close physical contact with the endothelium, that is number 2 in the figure. In the pulmonary circulation, where an extensive capillary bed, about 1000 capillaries per alveolus, exists, margination occurs because the capillaries are about the same size as a mature neutrophil. Therefore, neutrophil fluidity and deformability are necessary to make the transit through the pulmonary bed. Increased neutrophil rigidity and decreased deformability lead to augmented neutrophil trapping and margination in the lung. In the systemic postcapillary venules, margination is mediated by the interaction of specific cell surface molecules called selectins. Selectins are glycoproteins expressed on neutrophils and endothelial cells that cause a low affinity interaction resulting in rolling of the neutrophil along the endothelial surface. In the healthy adult, most neutrophils leave the body by migration through the mucous membrane of the gastrointestinal tract. Normally, neutrophils spend a short time in the circulation, that is half-life 6 to 7 hours. Senescent neutrophils are cleared from the circulation by macrophages in the lung and spleen. Once in the tissues, neutrophils release enzymes such as collagenase and elastase which may help establish abscess cavities. Neutrophils ingest pathogenic materials that have been opsonized by immunoglobulin IgG and C3b, that is a complement component. Note: Immunoglobulins. Immunoglobulins are also called antibodies. Antibodies are proteins that the immune system makes to fight germs such as viruses and bacteria. When exposed to germs, the body makes unique antibodies specifically designed to destroy only those germs. There are 5 types of immunoglobulins: IgG, IgM, IgA, IgD, and IgE. Complement. The complement system is a group of nearly 60 proteins that are in blood plasma or on the surface of cells. The proteins work with the immune system to protect the body from infections and to remove dead cells and foreign material. So, dear viewers, this is the end of part 1 of the 3-part series on the WBCs, granulocytes, functional aspects in the Medicine for Anyone in the YouTube channel. Thank you for watching the video.